Hi, this is second lecture on binomial distribution. Binomial distribution. In this lecture, we are going to discuss about mean of binomial distribution, variance of binomial distribution, moment generating function of binomial distribution, and we discuss some examples. So quickly revise what we have discussed about binomial distribution in last lecture. A random variable capital X is said to follow binomial distribution if its probability mass function is given by probability of x is equal to x. Sometimes we denote this by p of x or f of x, that is equal to ncx p की power x q की power n minus x, where x lies between x is 0, 1, 2 up to so on n, and 0 otherwise, or elsewhere it is 0. And the condition, that is, what is p and q? The sum of p and q, that is 1. Or we can say q is 1 minus p. So this is how we denote this binomial distribution. We also denote this by b, x, and p. These are the parameters for the binomial distribution. So, example, comment the following. Comment the following. Comment on the following. But the mean of binomial distribution, the mean of a binomial distribution is 3 and variance is 4. Variance is 4. So in last lecture, we have discussed about mean and variance of Bernoulli's distribution. But we will discuss how we can find the mean of binomial distribution and mean variance of binomial distribution in today's lecture. So what is mean of binomial distribution? Mean of binomial distribution is equal to binomial distribution is equal to n into p. What is variance? Variance is equal to npq. What is standard deviation? Standard deviation, that is equal to under root of variance of x, that is under root of npq. So these are the mean, variance, and standard deviation of binomial distribution. So we have to check whether the given condition satisfies it is true or not. The mean of binomial distribution is 3 and variance is 4. So the parameter of binomial distributions are, what are the parameters? Parameters of binomial distribution are n and p. Right? So we have given that mean is equal to mean of binomial distribution is equal to 4 is equal to 3. That is n into p is equal to 3. It is given. What is the second condition? Variance of binomial distribution is equal to 4. That is npq is equal to 4. So now we have to check, comment on the whether they satisfies uh, the condition for binomial distribution, that is whether we get np variance mean for the binomial distribution 3 and variance of binomial distribution equal to 4. So and here from variance what we find, q is equal to, we can write this as 4 upon np. And what is n into p? It is given mean. It is mean, so we can write this is 4 upon 3. And 4 upon 3 is 1.33, and which is greater than 1. So in binomial distribution, we have condition that p plus q must be equal to 1. Sum of p and q must be equal to 1. But here q is exceeded by 1, which is not possible. Right? So which is not possible. Is not possible since q cannot exceed unity. Since q cannot exceed unity. Hence the given statement is wrong. Hence the given statement is wrong. Okay. So now example 2. With usual notation, find p for the binomial variate x if n equal to 6 and 9 times probability of x equal to 4 is equal to probability of x is equal to 2. This question was asked in 2021 exam. So we have to find p for the binomial variate. For binomial variate, This is associated, this is noted by P binomial with parameter n and P. So n is given, n is equal to 6, and we know that binomial variate probability of x equal to x is given by ncx p की power x q की power n minus x for x equal to 0, 1, 2 up to so on n, and 0 otherwise, and 0 otherwise, and also it satisfies the condition p plus q equal to 1. So this is again important, right? So given that 9 time, given 9 time probability of x equal to 4 is equal to probability of x equal to 2. So it means 9 time NC4, here n is equal to 6. So I can write, given n equal to 6 and, right? So 6C4 P की power 4 Q की power 6 minus 4 is equal to 6C2 P की power 2 Q की power 6 minus 2. These are how we put the value of x is here, x is 4 and here x is equal to 2. So we put the value in this, we get, this implies 9 times 6C4 and 6C2 both have the same value. So we can cancel out this. P square and P4, this is cancelled. So we get 2 and 6C4, Q की power 6 minus 4 is 2 and 6 minus 2 is 4. So again, next step we can write P square Q4 Q square is equal to Q to power 4. So this implies that 9 Q square, 9 P square is equal to Q square. Or 3P whole square is equal to Q square. So we get, this implies that 3P is equal to plus minus Q, but Q cannot be negative. So we get, this implies 3P is equal to Q. This implies, or we can write, let this 3P equal to Q. This is the given. Now we find this. Let this be 1. Also, P plus Q equal to 1. So we can put Q equal to 3P. So P plus 3P equal to 1. So 4P equal to 1. This implies that P equal to 1 by 4. So the binomial variate n and P. Now we have to find P. So P is equal to 1 by 4. Right? So we can write n is 6 and P is 1 of 4. This is the binomial variate x with parameter n and P. So next example, find the binomial distribution whose mean is 9 and whose standard deviation is 3 by 2. Mean is 9 and standard deviation is 3 by 2. The parameter of binomial distribution of binomial distribution of N and P. So we have mean equal to 9, and mean means we know that mean of binomial distribution is NP, so NP equal to 9. This is the first given condition. Also, standard deviation equal to 3 by 2, and standard deviation is under root NPQ, that is equal to 3 by 2. Squaring both sides, we get NPQ equal to 9 by 4. And now NP is given. N into P is equal to 9. So we can put NP, that is 9. 9Q is equal to 9 by 4. So this implies that Q is equal to 1 by 4. So we can find Q. If we find Q, then we can find P. Since P plus Q equal to 1, this implies that P equal to 1 minus Q. This implies that P equal to 1 minus 1 by 4, that is equal to 3 by 4. So we can find P. Now we have to find N. Since we know that from this equation, NP equal to 9. So since also N into P equal to 9. So N into what is P? That is 3 by 4 equal to 9. So this implies that N is equal to 9 into 4 by 3. So N equal to 12. So now we have P as well as we have parameter N. So N is equal to 12 and P is equal to 3 by 4. Also, we know that Q is equal to 1 by 4. Therefore, the required binomial distribution is equal to P plus Q to the power N. That is, P is 1 by 4, so P is 3 by 4 plus 1 by 4 to the power 12. So this is the required binomial distribution. So let us come to the next topic, mean and variance of a binomial distribution. The mean and binomial variance of binomial distribution and variance of binomial distribution with parameters N, P are given by first mean is equal to expectation of X, that is equal to summation I equal to 1 to n, or we can write this is equal to np. Right. Second, variance, that is expectation of x square minus expectation of x whole square, that is equal to, we also denote variance by sigma square. So sigma square is equal to mean by mu. So mu is equal to this, mu equal to np, sigma square, that is variance, variance is equal to n into p into 1 minus p, and that is nothing but np cube. np cube. So mean of a binomial variance distribution is np, and variance is equal to np cube. We have to prove this. We know by definition mean is equal to, mean mu is equal to expectation of x, that is equal to summation I equal to 1 to, or we can say x is equal to 0 to n infinity, x equal to 0 to infinity, x into probability of x is equal to x, that is summation x equal to 0 to infinity, x into, we also denote this by fx or px, x into fx. And what is fx for binomial distribution? It is only defined for x equal to 0 to n, x into, and otherwise it is 0. Right? We only take the value x from 0 to n, x into ncx p की power x, q की power n minus x. So that is equal to summation x equal to 0 to infinity, 0 to n, x into, now if we open the bracket, then it is n factorial upon ncx. ncx is n factorial upon x factorial into n minus x factorial into p की power x, q की power n minus x. We can also expand this, also rewrite this x into, we can write this as n into n minus 1 factorial, and this x as x factorial as x into x minus 1 factorial. We also write this n minus x as n minus 1 minus x minus 1 factorial into p की power x. So we can write this as in term of x minus 1. So what we do, p into p की power x minus 1. When we base are equal, power are added, right? So it is again p की power x into q की power n minus x. So we can again use this, because for n minus x we can write n minus 1 minus x minus 1. So we can write n minus 1 minus x minus 1. So and then bracket close. So this x and this x cancel out. We can take this n and this p to be common, np common. Now this become x is equal to this. Our x starts from 0. Instead of 0, it starts from 1. X is equal to 1 to n minus 1 factorial divided by x minus 1 factorial into n minus 1 minus x minus 1 into p की power x minus 1 into q की power n minus 1 minus x minus 1. And if we check this whole term in this summation, we can write this as p plus q की power n minus 1. This is the binomial distribution. If we expand this, then we get p plus q की power n minus 1. Okay? Because if, let us do this, let us do one more step. We can write this as x equal to 1 to n. We can write this term as n minus 1 c x minus 1. p की power x minus 1, q की power n minus 1 minus x minus 1. Now this whole term under in summation, it become np into p plus q की power n minus 1. And we know that p plus q equal to 1, so it is np. So mean of a binomial distribution, that is equal to np. So let this be 1. So expectation of x, that is mean. So mean of a binomial distribution equal to np. Okay. Now second, we have to find variance. And for variance, first we have to calculate expectation of x square, because expectation of x we have already calculated. Now we have to only find out expectation of x square. So first we find expectation of x square. And what is expectation of x square? Summation x is equal to 0 to infinity x square into probability of x is equal to x. And we denote this by x is equal to 0 to infinity x square into fx. And what is f function fx? X square x equal to 0 to infinity x square into ncx p की power x q की power n minus x. And it is only for 0 to, not for infinity, but only for 0 to n. For other values of x, it is 0. Now, when we calculate expectation of x square for binomial distribution, we have to one point that is important. We have to write this x square. We have to write this x square. How we can write this x square? We can take summation x is equal to 0 to n x square as x into x minus 1 plus x into ncx p की power x q की power n minus x. So here point to remember. Expand or write x square as x into x minus 1 plus x. So this is the important point to be remembered. So We can write this as x equal to 0 to n x into x minus 1 into ncx p की power x q की power n minus x plus summation x equal to 0 to n x into ncx p की power x q की power n minus x. And this term we have already calculated. This is nothing but this is mean, and this is equal to n into p. So we have to calculate only the first term. Right? So this is equal to x is equal to 0 to n x into x minus 1 ncx p की power x q की power n minus x plus np by using 1. Now let this be 2. So this is expectation of x square. Now we have only calculate expectation of summation x equal to 0 to n x into x minus 1 ncx p की power x q की power n minus x. Now consider this term, the first term of equation number 2. Summation x is equal to 0 to n x into x minus 1 ncx p की power x q की power n minus x. That is equal to summation x is equal to 0 to n x into x minus 1. What is ncx? N factorial divided by x factorial into n minus x factorial p की power x q की power n minus x. Here x, for x we expand x to be x into x minus 1 into x minus 2 up to x minus 2, because x and x minus 1 both are cancelled. So we can expand this x as x is equal to 0 to n. Even we can, if we expand this up to, so first x equal to 0, so we can write x into x minus 1 n into n minus 1 n minus 2 factorial divided by x into x minus 1 x minus 2 factorial. Similarly, we can write n minus x as n minus 2 plus also minus x minus 2. We write n minus x factorial as n minus 2 minus x minus 2 factorial and p की power x. So we can write p square into p की power x minus 2, and for q की power n minus x as n minus 2 minus x minus 2. Minus x minus 2. So x minus 2 cancel out. So we can write summation. Even we can take the term common. What is the common term? N into n minus 1 into p square. We take this to be common. Now summation x varies from 2 to infinity, 2 to n now, right? N minus 2 factorial divided by x minus 2 factorial n minus 2 minus x minus 2 factorial p की power x minus 2 q की power n minus 2 minus x minus 2. Now the term in the bracket in the summation, it again become binomial distribution, probability distribution function for binomial distribution, that is n into n minus 1 p square. So we can write this as p plus q की power n minus 2. And we know that p plus q equal to 1. So we can write this as n into n minus 1 p square. So let this be 2, 3. So this is our third. So we put the value of this expression in equation 2. So from now equation 2, now from 2, expectation of x square, that is equal to n into n minus 1 into p square plus np plus n into p. So when we solve this, we get n square p square minus np square plus np. This is expectation of x square, right? So now we come to variance. Now variance of x, that is expectation of x square minus expectation of x whole square. Expectation of x square, that is equal to n square p square minus np square plus np minus expectation of x is np whole square. So n square p square minus np square plus np minus n square p square. This term is cancelled out. So we can take np to be common. So it is minus p plus 1 and 1 minus p, or we can write this as np into 1 minus p, and 1 minus p is q. So it is npq. So variance of x is equal to variance of binomial distribution is equal to npq. So this is how we can prove that variance of a binomial distribution is npq and mean is np. Now the next term is moment generating function. So we denote this, we use MGF for moment generating function of a binomial distribution. So the definition, how we can define moment generating function MGF, that is denoted by mx t, that is equal to expectation of e की power tx, and we know that how we can define expectation, summation x equal to minus infinity to infinity e की power tx into probability of x equal to x, and we also denote this probability of x equal to x as f of x. So we can put the value of fx, summation x is equal to minus infinity to infinity e की power tx into ncx e की power x q की power n minus x, and we can take term to be common in the bracket because it is a binomial distribution, so it is defined only for here. We can write x is from 0 to n. 0 to n. X is 0 to n. NCX t into e की power t whole power x plus into q की power n minus x. We combine p into e की power p की power x into e की power tx. We can take p into e की power t whole power x. So it is again become a binomial distribution. Here our p is p into e की power t. So we can write this as p into e की power t plus q की power n. So this is the moment generating function. Moment generating function for binomial distribution, that is mxt, that is p e की power t plus q की power n. So this is how we can define moment generating function for binomial distribution. So let us discuss one example how we can find mean and variance with the help of moment generating function. So example, find the mean and variance of a binomial variate capital X whose moment generating function is as follows. What is moment generating function? Mxt, that is equal to, it is given 4 by 5 plus 1 by 5 e की power t whole power 6. So since we know that mxt moment generating function for binomial distribution is, we can also write this as q plus p e की power t की power n. So here if we compare this, we get q equal to 4 by 5, p equal to 1 by 5, and n is equal to 6. So it satisfies p plus q equal to 1. P plus q, that is equal to 1. It satisfies. So the binomial distribution, so mean is equal to, we know that mean of binomial distribution, that is equal to np. So that is 6 into 4 by 5, 1 by 5. So mean equal to 6 by 5. And variance, that is equal to npq. So 6 into 1 by 5 into 4 by 5, so 24 by 24. So in this way we can find mean and variance of a binomial distribution with the help of moment generating function. In next video lecture, we will discuss some examples related to moment generating functions and how we can find mean and variance if the moment generating function is given. So thank you. Have a nice day.